On this Ram 2500 HD with the 6.4 gas engine, P0352 is an ignition coil primary circuit fault for coil 2. In plain language, the PCM may not be seeing the expected current behavior on that coil control circuit. The driver may notice the MIL, and the engine may run rough, stumble, or misfire depending on when the fault is active. Broadly, this can involve the coil power feed, the coil 2 control circuit, the coil and plug condition, connector issues, or the PCM driver. Before getting deep into pinpoint testing, start with the basic system checks and follow a structured diagnostic approach. For this circuit, the ignition coils are supplied 12 volts from the fused ASD relay output, and the PCM controls the low-side driver to build and collapse the coil field. This monitor runs continuously with the ignition on. The code sets when the PCM detects ignition coil 2 signal circuit current less than or equal to 0 amps for at least 1-2 seconds. When it sets, the default action is that the MIL will illuminate. Start by reading DTCs in all electronic control units and record what was stored along with the environmental data. Save the scan report and related recorded data so you know the conditions that were present when the fault set. Clear the DTCs, turn the ignition off for a minimum of 10.0 seconds, then turn the ignition back on. Reproduce the operating conditions that set the code, using the captured conditions as your guide, and read the codes again. If P0352 returns, continue with the circuit diagnosis. If it does not return, treat it as an intermittent condition instead of guessing at parts. Next, look at the codes you recorded before narrowing in on coil 2. If there are ASD-related codes present, diagnose those first, because the coil primary feed comes from the fused ASD relay output circuit. If there are no ASD-related codes, move on to testing the coil 2 power supply circuit. Disconnect the ignition coil 2 connector so you can access the power supply circuit. Connect the positive lead of the load test tool to the power supply circuit at the coil 2 harness connector, and connect the negative lead to battery ground or chassis ground. Make sure that circuit is actually being powered on. If it is an ignition feed, the ignition needs to be on. If it is relay output, verify the relay is energized and on. The load test bulb should be illuminated and bright, and you should compare that brightness to a direct battery connection. To verify the circuit with more certainty, perform a voltage drop test across the 3156 bulb in the load tool. A 12-volt test light can be used only if it draws enough current to load the circuit. Many high-impedance test lights draw less than 0.1 amps and are not reliable for this. For a proper load test, the tool should draw more than approximately 0.75 amps. If the bulb is bright, continue. If it is not bright, repair the power supply circuit for an open or high resistance, then verify the repair and confirm the code stays gone. Now check the coil 2 control circuit. Use a 12-volt test light connected to a 12.0-volt source and probe the coil 2 control circuit at the ignition coil harness connector. While doing any cranking or running checks, stay out of the direct line of the fan, keep hands away from pulleys, belts, and the fan, and do not wear loose clothing. Crank the engine for 5.0 seconds while watching the test light. If the light is brightly blinking, the control side is being pulsed, so move to the spark plug inspection. If the light is on constantly, follow the short-to-ground path. If the light is off constantly, follow the open or high-resistance path. If the control circuit is brightly blinking, turn the ignition off and remove the spark plug or plugs using the correct removal procedure. Inspect for cracks, carbon tracking, foreign material, gap size out of specification, and any loose or broken electrode. If any of those conditions are present, replace the spark plug. If carbon tracking is found on the spark plug, inspect the ignition coil boot for damage and replace the boot if necessary. If none of those spark plug conditions are present, the diagnostic path calls for replacing the ignition coil and spark plug, then verifying the repair and confirming the code stays gone. If the test light stayed on constantly during the control circuit check, isolate the coil 2 control circuit and check it for a short to ground. Turn the ignition off, disconnect the ignition coil 2 harness connector, and disconnect the PCM harness connector. Then check continuity between ground and the control circuit at the ignition coil 2 harness connector. If there is continuity to ground, repair the control circuit for a short to ground. Then verify the repair and confirm the code stays gone. If there is no continuity, continue to the coil swap test before making a PCM decision. If the test light stayed off constantly, check the coil 2 control circuit for an open or high resistance. Turn the ignition off, disconnect the ignition coil 2 harness connector, and disconnect the PCM harness connector. Do not probe the PCM harness connectors directly, because that can damage the terminals and cause poor terminal-to-pin contact. Install the adapter, GPEC Diagnostic 10436, to the appropriate PCM harness connector. Keep in mind that this adapter can add up to 1.5 ohms of resistance to the circuit. Measure the resistance of the control circuit between the ignition coil 2 harness connector and the PCM harness connector. If resistance is below 3.0 ohms, continue to the next stage. If it is not below 3.0 ohms, repair the control circuit for an open or high resistance. Then verify the repair and confirm the code stays gone. Before replacing a PCM, determine whether the ignition coil is the cause of the driver failure. An internally shorted or damaged secondary coil circuit may be the reason the PCM coil driver failed, so do not replace the PCM without checking this first. Remove the ignition coil controlled by the driver that's set P0352 and install that coil in another coil location that did not have a code set against it. Turn the ignition on, clear DTCs, then start and run the engine for up to 1 minute. If the engine will not start, crank the engine 3 times for 10 seconds. Read DTCs again. If a correlating fault sets for the new coil location, the path calls for replacing the ignition coil and replacing and programming the PCM, then verifying the repair. If no correlating fault sets for the new coil location, continue to the connection checks. At this point, check for any applicable service bulletins. Then inspect the related PCM and component connections. Disconnect the PCM connectors, any related inline connectors if equipped, and the related component connectors. Look closely for poor connector installation, damaged locks, corrosion, water intrusion, weather seal damage if equipped, bent terminals, overheating or discoloration from a poor connection, and terminals pushed back in the connector cavity. Also check for spread terminals and verify proper terminal tension. Repair any conditions found. Then reconnect the PCM connectors, inline connectors if equipped, and related component connectors, making sure every connector is fully seated and every lock is engaged. Clear the DTCs, test drive or operate the vehicle under the conditions that run the monitor, and read DTCs again. If P0352 returns, the path calls for replacing and programming the PCM, then verifying the repair. If it does not return, the wiring or poor connection issue has been repaired. Keep verification separate from the pinpoint tests. After any repair, confirm the code stays gone under the conditions that originally set it. Bottom line: prove the fault is current, prove the feed can carry load, prove the control circuit can pulse, and only make the PCM call after the coil and connections have been checked. For more diagnostic training, visit stepdiagnostics.com.